we're going to want to do in all of these questions is always factor first. That's going to come into effect for part C, and that's why cross multiplication isn't going to work well for part C. For part C, can you see if you cross multiply an x squared times an x, you'll get an x cubed. And that will cause you, in order to solve this one, to have to factor an x cubed. And you don't know how to do that yet. So that's hard when you don't know how to do something. You will learn that next year, how to factor x cubes, yes. But right now, not. But in the first one, there, it's already factored. We could use the cross multiplication because it's a fraction equals a fraction. Or we can just say to ourselves, if I wanted to get a common denominator, and again, I will go back to those two strategies that we used in the first example because they explain why the cross multiplication works. For example here, if I wanted to get a common denominator, do you see that this one I would need an x minus 3 and an x minus 3? And this one I would need an x plus 2 and an x plus 2. And now that I have a common denominator, if I were to multiply both sides by that common denominator, these things would cancel out. And in a sense, all that's happened is the x plus 2 has moved up there, and the x minus 3 has moved up there. Hence the cross multiplication shortcut rule, but you can see why it works when we use our other technique. And now when we multiply through, we're going to get negative 3x plus 9 equals 2x squared plus 4x. And so what happens in all of these questions, this is really where math is building on each other, right? We're learning new techniques to get rid of fractions, which is based on something we've learned before. So it's not really that new, but it's a new situation. And then after getting this far, we run into another situation, which we've dealt with before, is solving an equation that has an x squared. So that should cue for you that I need to get one side equal to 0. And if I do get that side equal to 0, adding 3x to both sides, we'll end up with 7x. Subtracting 9 to both sides will give us minus 9. And this one is easier to factor, because what is our only option with 2x squared? 2x and x. So then you have to see with 9 how you could possibly get 7 with your outside and inside. You see that 9 and 1? Nope. That makes 18 and 1. How about 9 and 1 this way? That gives me 2 and 9. That makes 7. I would need to have my 9 positive, my outside 2 negative. X equals negative 9 over 2, and x equals 1. What were our non-permissible values?
0 and -0.
No. Let's look at our original equation. Here we're dividing. Negative 2 would make us divide by 0. So that's one non-permissible value. And 3 would make us divide by 0 in the other one. Since neither of our answers are those non-permissible values, both of them are correct. They'll always be the opposite of what's on the bottom, except for like when you have an x squared minus 9, you'd have to factor that first. It'll also sometimes be, if it was 2x minus 5, it's not exactly the opposite, right? You're always checking to see what is it on the bottom that would make it equal to 0, because you're not allowed to divide by 0. And often that is just the opposite, because what plus 2 is 0? Negative 2. What minus 3 is 0? 3. So it is often the opposite. So for part B, again, I'm going to show getting the common denominator And then you can see why when these cancel out, because if you would multiply both sides by x minus 1, x minus 5, you can see that this is one where cross multiplication makes the most sense. And here on the top, I have to FOIL it out. X squared plus x minus 2. And here I'd have to distribute x squared minus 5x. Combine your like terms. Move everything. You see a quadratic, you say, I need to move everything over to make it equal to 0. I've got x squareds on both sides, and when I move them over, they go away. So I end up with 6x minus 2 equals 0. So this sometimes throws a person off, because you get into your mindset that you're thinking solving a quadratic, but then when you bring everything over and make it equal to 0, it's no longer a quadratic. So you have to go back in your memory even further. How did you solve these in grade 9? Just add 2 to both sides, right? It's just getting x by itself. But sometimes when that appears in the middle of a question, you just sort of freeze and go, I am, ah. Does that ever happen to you? Get that moment in math. No, you just need to get the x by itself. So move the 2 over, divide both sides by 6. That fraction reduces to 1/3. What are our non-permissible values? Because we have to check if 1/3 is actually an answer. Well, original equation, x can't be 5. X can't be 1. So 1/3 is fine. And then one more to go. This is part C. Is an excellent example because it shows us why just going to cross multiplication right away can cause problems. Again, we always check to see if we can factor things and simplify first. X squared minus 9 does factor. It's a difference of squares to x plus 3, x minus 3. Now, if we wanted to get a common denominator, notice there's already an x minus 3. So the only thing you would need to get a common denominator is an x plus 3. Whoa, that's a hard 3. Notice that if I would have cross-multiplied, I would have added an extra thing on the top on the left and an extra x minus 3 on the top on the right, which would have given us an x cubed. And a question like this happened, I don't know if it was last year's exam or 2 years ago, and a lot of students that went to that cross multiplication got stuck at the very first step and they couldn't do anything with the equation and spent a lot of time with a very complicated equation. So factoring first and then realizing that you only need to multiply by the x plus 3 to get a common denominator. Now when you multiply both sides by x plus 3 and x minus 3, those would cancel. FOIL this one out. Again, I have an x squared, so I'll make one side equal to 0. Plus 15. Ooh, very cool. And then when you factor this, x and x is perfect squared trinomial, you get x equals 3 2 times. Check our non-permissible values. What can't x equal? Well, we'll have to check once it's factored. X can't be negative 3, and x can't be 3. Oops, keep that green.
Except there's only one major.
Ooh.
X is 3.
So both of these are extraneous. They're both things that would have made the original equation explode. And since we end up with no answers that work, the solution to this one is no solution. And just because a question has no solution does not mean that if you left it blank on your test, you would get full marks. Right? You can't just say, well, I provided no solution. Why can't I get full marks for that one? You have to always show your work, even when there is no answer to your answer. Okay, the ones for this one are 6 and 7.